All right, and now we're going to go ahead and go to a item called solving equations. We've only been dealing with expressions so far. Now we're going to go ahead and look at solving equations. So how does this differ from what we've been doing? Well, we've been simplifying expressions. Okay, and what's going to happen here is we're going to have the basic definition of an equation is an expression equals an expression. Okay, so we got some stuff over on this side and some stuff over on this side, and our goal is to have a variable equal to a number of some kind. That's our goal. The variable could either be on the left or on the right, depending on what you prefer. Okay, but our goal is to get the variable on one side by itself, a numerical value or a number, a constant on the other side. The first thing we're going to talk about is the addition property of equality. And all the addition property of equality says, it says if I have some value A, and for some reason that value is equal to B, it allows me to go ahead and add the same value on either side without changing the equality of it. It means the sides are still equal. I could also go ahead, I need to leave a little more room here, sorry. If I have A is equal to B, it also means I can go ahead and subtract the same number from both sides without changing the equality of the equation. Okay, so basically to undo what we call undoing, adding, and subtracting, we need to do the opposite operation, but we need to do it to both sides. Makes more sense when we see some examples. Let's go ahead and do that. All right, so over here I have x minus 2 is equal to negative 1. All right, and remember my goal is to get the variable, my x, by itself, and all the numbers over here. And I have a minus 2 here. Now the opposite operation of subtraction or minus is plus, which means to go ahead and add 2 to both sides. These are now opposites. And if I have minus 2 and plus 2, I end up with a 0, which makes those go away. All right. That leaves me with x plus 0, but anything plus 0 is just itself. So I really just have x. And whatever I do to one side, I must also do to the other. So I have to add 2 with the negative 1. Now negative 1 plus 2, I have $2, I spent 1, is equal to 1. So therefore, x is equal to 1. Now I can check this. Is 1 minus 2 equal to negative 1? Indeed it is. So this checks out, so you can check all of these. Okay, for the next example here, I have x plus 4 is equal to 6. Right. So I have a plus 4 with my x, and I want to get rid of the plus 4, so I need to minus 4. And whatever I do to one side, I got to do to the other. These are opposites on this side. They are going to cancel out. I'm left with x on one side, and 6 minus 4 is equal to 2. Okay, the next ones are kind of, for some people it bothers you because now our variables are on the right-hand side, and it really doesn't matter for equations if they're on the right or on the left. I still want to go ahead and get my number over to the other side away from my y, so my y is by itself. So I need to go ahead, if I have a plus 1, I need a minus 1. And I need to make sure I'm doing it on both sides. Now make sure you're aware of where your equal sign is at, because that's what splits the equation in half. Plus 1 minus 1 gives me 0, or cancels out. And on this side I'm left with only y. So y is equal to negative 8 and negative 1, same signs. We've got to add and keep the sign, so it's -9. We can check this. Is -9 plus 1, negative 8. If that's true, we are good to go. Last one here, I have a y minus 2 on the right. I have a minus 2, so that means I need to plus 2. Be mindful where my equal sign is, and plus 2 on this side. These cancel, leaving me with y, and 7 plus 2 is positive 9. Okay. So that's the addition property of equality. Next we have the multiplication property of equality, and it basically means the same thing as we were talking about with addition and subtraction. So if I have a value a that is equal to b, I can multiply both sides by the same number c, and they're still equal. It also means if I have a equal to b, then I am allowed to go ahead and divide both numbers both values by the same number, as long as that number is not 0. So in this case, I have to put an extra thing here. C cannot be equal to 0 because 0 in the bottom of a fraction makes it undefined. So we can't do that. Let's go ahead and look at some examples with this property. So here I have negative 6x is equal to negative 18. The 6 and the x are being multiplied together. The opposite of multiplication is division. So we want to divide both sides, not only by 6, but we want to take the negative with it. We never solve for a negative value. So if you have a negative in front of your coefficient, you have to take it with you. Now, negative 6 divided by negative 6 is equal to 1, or 1x. You don't necessarily need to write the 1. And whatever I do to one side, I must do to the other, so the 18 that's negative must be divided by negative 6. Now, a negative and a negative give me a positive. That's my rules of integers. And 18 divided by 6 is 3. Now, I don't mind personally if you leave the 1, but we don't normally do that. So x is equal to 3. I can still test this. Is negative 6 times 3 equal to negative 18? Well, negative times a positive gives me negative. 6 times 3 is 18. We are good to go. So make sure you're checking these. Here we have y on the other side. So I have a negative 7y on this side. I have multiplication between the negative 7 and the y, so I need to divide by negative 7. Remember, I got to take the negative with me. Everything's going to cancel on this side except for the y. And whatever I do to one side, I must do to the other. And a negative and a positive gives me a negative, and 21 divided by 7 is negative 3. Right, 2 more to go here. So these both have division involved. Okay, so I have x divided by 3. The opposite of division is multiplication. So I'm going to multiply this side by 3, or 3 over 1. When I do that, I have 3x divided by 3. 3 divided by 3 is equal to 1, or 1x. And again, we don't normally write the 1, so I'm just going to write an x. Whatever I do to one side, I have to do the other. So the negative 4 must also be multiplied by 3. Here I don't need to make 3 a fraction, so I'm okay. And negative 4 times a positive 3 is negative 12. These we usually want to go ahead and check. So is negative 12 divided by 3 equal to negative 4? Well, negative and a positive gives me the negative. And 12 divided by 3 is 4, so it all checks out. Same thing with the last one. This one I want to go ahead, and I have a 5 being divided by x, so I must multiply both sides by 5. When it's a fraction, I like to make it 5 over 1, so I can see that it cancels out. When it's a whole number, I don't necessarily do that. So 5 divided by 5 cancels out, becomes 1. 1 times x is x. And 8 times 5 is 40. And again, because it's division, I want to test this. So 40 divided by 5 is indeed equal to 8. I'm good to go. Okay. So we'll be putting these together starting tomorrow. Be comfortable with one or the other. These problems only have either the multiplication property of equality or the addition property of equality, and we'll start mixing them up tomorrow. So make sure you do the practice problems, and I'll see you then.